Okay, so question number 9. Explain whether N2 is polar, ionic, or nonpolar. Then describe and explain whether it is soluble or insoluble in water. First, let's draw out the Lewis structure of this N2, which is nitrogen gas. So nitrogen contains 5 valence electrons, and there are 2 atoms of nitrogen bonded together, so we multiply this by 2, giving us a total of 10 valence electrons. So now, if I only draw a single bond and try to fill out the octet, we have more electrons than we need. So we already have 12, 13, 14. So let's bring a pair of electrons down to form a double bond. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we still have more electrons than we need. So again, let's form another bond. And now this should give us our Lewis structure of N2. It contains 10 valence electrons. The nitrogens have a full octet, and each has 1 lone pair. So now let's try to answer the question about polarity. Explain whether it is polar, ionic, or nonpolar. So already we can cancel out the fact of it being ionic, because ionic is only between a metal and a non-metal. So ionic bonds are with a metal and a non-metal. So already we can cancel this out. And now we need to talk about polarity. So when we have a polar molecule, this is when there is a difference, or when we have a polar bond in particular, this is when the bond has a difference in electronegativity due to one of the atoms being more electronegative. But when we have a nonpolar bond, this is when the 2 atoms either have the same or similar electronegative values. So typically, the difference in electronegativity is less than 0.4. So notice that with nitrogen, well, with these 2 nitrogen atoms, they're the same. So obviously they're going to have the same electronegativity values. So this is why the bond is nonpolar. And also, if we look at the entire molecule, it is also symmetrical. So even if they were different and we had dipole moments, then they would point in the directions of the 2 atoms and cancel each other out. So this is why we have a nonpolar molecule. So it is diatomic, and on top of that, it's symmetrical. . and it has a 0 dipole moment. Okay, so now for part B. Describe and explain whether it is soluble or insoluble in water. Okay, so I'll draw out the water molecule, which everyone knows is H2O. Oxygen has 2 lone pairs, making it have this kind of bent structure. And also, oxygen is more electronegative than hydrogen. So we are going to have a non-zero dipole moment pointing towards our oxygen, and our oxygen has a partially negative charge, and the 2 hydrogens are partially positive. So because of their difference in electronegativity, and because of this dipole moment, water is a polar molecule. So since like dissolves like, then that tells us that N2 is insoluble in water. Okay, so again, since water's polar and N2 is nonpolar, then N2 is insoluble in water. And the junior tutor said, to answer this question, we must first understand the concept of polarity and its relationship with solubility. Polarity is a molecular property in which electrical charges are distributed between bonded atoms. It is closely related to the electronegativity of atoms and the shape of the molecule. Firstly, the difference in electronegativity values of chemically bonded values and determine the type of bonds present in a molecule shown in the table below. Electronegativity values can be obtained from Pauling's scale. Yep. I think even if you have a difference that is 1.67, it still could be polar covalent. So it just depends on, everyone has different scale values. Anyways, however, this alone cannot determine the polarity of a molecule. In some cases, a molecule that comprises of polar bonds has a nonpolar polarity. This can be associated with the shape of the molecule and how dipole moments can cancel each other. From the given question, N2 is a diatomic molecule. It is important to note that diatomic molecules take up a linear geometry as shown in the figure below. In this given conformation or configuration, since N2 consists of not just similar atoms but the same atom, the electron distribution at both ends of the structure is the same, which cancels out both their electron dipole moments. Consequently, since they are the same atom, the bond type will be nonpolar covalent, and the difference of the electronegativities will equal to 0. Hence, we can say N2 is a nonpolar molecule. On the other hand, solubility is a property of molecule to be dissolved in a given solvent. Its relationship with polarity suggests that if a molecule has the same polarity with the solvent, the molecule will be soluble. This is what scientists refer to as like dissolves like, meaning substances with similar polarities are soluble to each other. Okay, so they showed the structure of water and how oxygen has a partially negative, partially positive side, making it a polar molecule. Then they said that N2 is insoluble in water because they have different polarities. Yep, so the solution is correct.